And I'm recording. All right, welcome to Tech with Kareem, everybody. My name is Kareem. I'm a software engineer based out of Boston. And for my first video, I wanted to run by the question TwoSum. So the question or the problem TwoSum is a very popular interview question, whether you go for any type of software engineer jobs or things of that nature. It's a pretty staple. And a lot of times you'll see the implementation done in languages such as JavaScript or Python, but today I wanted to focus on giving an implementation for C Sharp. Let's switch it up a little bit. So let's get right into it. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. For the first example, we have this nums array. We have the numbers 2, 7, 11, 15, and we have a target parameter of 9. And the output would be 0, 1. Explanation. Nums 0 plus nums 1 equals 9. So we return 0 to 1. So this is essentially saying that the number 2 would be the index 0, and the number 7 would be the index 1. And 2 plus 7 equals 9, so the output would be an array with the two indexes 0 and 1. If we go to example 2, we'll see the same thing. We'll see an array 3, 2, 4, and the output would be 1 and 2. Why? Because index 1 would be 2, index 2 would be 4, 2 plus 4 equals 6. And for example 3, we have an array of two elements, 3 and 3, and the output would be 0 and 1, such that the index 0 would be 3, and the index 1 would be 3, and 3 plus 3 equals 6. Something to keep in mind is that, as you can see, you may assume that each input would have exactly one solution, and you may not use the same element twice. So that's important to keep in mind because, let's say, for example, this third example, an output of 0 and 0 would technically still work. Why? Because the 0 index represents the number 3, and 3 plus 3 equals 6. But because we can't use the same element twice, that would be invalid. So that's something that we have to keep in mind. Okay, so how do we actually solve this problem? One brute force technique that you can use that is pretty native is what you can do is that you can run a for loop, and inside that for loop you can run another nested for loop, and you can look for a number that corresponds with target minus that outer for loop index number. So for example, if the I index would be at 2 and we have a nested for loop, that nested for loop would be looking for 9 minus 2. In this example, that would be 7, which is why 0 and 1 would be the output. So let's try to implement that. It's always better to try it. So I'm going to create a for loop, and I'm going to iterate through the length of the array. And I'm going to increment by 1. And I'm also going to run a nested for loop or inner for loop as well. And I'm going to call it j. And I also want to iterate through the whole array. So j less than nums.length. And let's increment j. Now inside this for loop, what we're looking for is that we're looking for target minus nums I, because we know that that would correspond for the correct answer. So what we can do is that inside, on the outer for loop, I can make a variable, and I'll call it new target, once I learn how to spell. And I'll just set that to target minus nums I. So for example, at the first index, this would correspond to 9 minus 2. Why? Because target would be 9, and nums I would correspond to 2. Now inside this inner for loop, there's one thing. The first thing I'm going to do is that I'm going to make sure that we're not dealing with the same index. So I'm going to make a pretty simple check. If I equals to j, let's just continue. We don't want to deal with it. We're not going to do anything. We're just going to act like it never happened, okay? Now, then we can make a second check, which is if nums j is equal to new target, we can just return a new array, and we can just have I and j, and the order shouldn't matter. Now, because this is C#, we have to return something. We can't leave and I'll just return that. That should never hit because there should always be exactly one solution, but we'll get an error if we don't do that. Now let's try to run this code. Let's see if this works. Okay, the basic test works. Let's try submitting it. Cool. It worked. Now let's try a different implementation. Now the problem with this implementation is that this implementation for my time complexity would be O of n, such that we are essentially, for every single index in this array, we are iterating through the whole array. So think of the length of this array cubed. I'm sorry, not cubed, squared. So if the array had 4 elements, we'd be iterating 16 times. If the array had 5 elements, we'd be iterating 25 times. Not very efficient. So we want something efficient. We would preferably want something O of n. Essentially, we'd only have to iterate through this array once, you know. We would only iterate up until the length of the array. Maybe less. So let's try to implement that. First, let's actually just try to reset this. I'm just going to backspace all of this. Why not? Cool. So let's think of an implementation that also works for this problem. Now, as you remember on our last example, what we were doing is that we kept iterating through this array, but every single time we would fall into an index, we'd iterate through the array again. And we don't necessarily do that. We don't necessarily need to do that, because what we can do is that while we're iterating through this array, we can keep a reference of each element in that array, and we can also store its index. So what would be a good data structure to accomplish that? A dictionary, you know, or a map. So let's write that out. I'm going to create a dictionary, and I'm going to have the key be type integer and the value integer. I'm going to call it dict equals new dictionary. Key value of integer. We want to keep that. All right, cool. So now I'm going to run one for loop, like I said. One, you're going to iterate through the length of the array. I'm going to call it I. I'm going to start at 0, and I'm going to iterate through the length of the array. Now what I can do is that while I'm iterating through this array, I can have a check that checks to see if nums I is not in this dictionary. Let's add nums I into this dictionary, and let's have the key be the number and the value be the index. So let's implement this. If dict dot contain key nums I equals or equates to false, we're going to set dict nums I equal to I. So what we're doing is that we're saying that inside this dictionary, we're going to store the key as nums I, and we're going to set the value to I. So for example, for index 1 or index 0, the key would be the number 2 and the index would be 0, hence the index 0. So if dict contains key is equal to false, if it doesn't contain nums I, we're going to set nums I as I. And our next check we're going to do, what is the next step? So we set nums I inside this dictionary. The next step that we need to do is that we need to make sure, we need to have a check to see if this dictionary also contains target minus nums I. So the same implementation. The only difference is that we have a reference to that number that we don't have to iterate again through. So the way I can write this is that up here I can write another for loop, and I can say if dict dot contains key target minus, you know what, I'll make a variable for this. Let's make a variable. We'll call int new target equals target minus nums I. Cool. And then if dict contains key new target, we should just be able to return a new array. And I can have I, and then to get the index of the new target, what the syntax we need to do is that we do dict, and then we just use new target. New target representing the key, and this altogether representing the value. Okay, let's try it. And we also have to return something at the end. Okay, so I'll just return an empty array for now. Shouldn't matter, right? Okay, so our basic test worked. Let's try submitting this. And boom, we passed. So that's all I have for today, everybody. Hope somebody learned something today. I'm looking forward to seeing everybody again. Have a great day.